Alright, so the past couple days we've been talking about sine and cosine graphs. Today we're going to talk about tangent graphs, and that's going to be the end of our trig graphs that we're going to look at. We're not going to talk about secant, cosecant, or cotangent, or any of the inverse trig graphs, just sine, cosine, and tangent. So today we're going to look at tangent. Alright, tangent is still a periodic graph. It still keeps repeating itself forever and ever, but instead of being one connected smooth wave, it is multiple little curved lines. Okay? They have what we call asymptotes, which are lines that the graph approaches, but kind of gives it a border. It can't touch or cross them. So it's got that line. It's not going to ever actually reach it. It's just going to keep getting closer and closer and closer and closer and closer to it, but it's never actually going to get to that line. Okay, we've got one over here, and they kind of separate each piece of this graph. With sine and cosine, one of the things that we were concerned about finding was our amplitude, which was a height. Tangent doesn't really have an amplitude because it goes up and down forever, but there's still a height that we're going to care about. And on the notes, and then the quiz, it says something about the height of the first point. What I mean is the point that is going to be right exactly halfway between our center. So we're still going to have our center point that we're going to plot. Then we're going to plot a point halfway between and symmetrically halfway back. And we're going to plot those 3 points to define our curve, and then we'll have our two asymptotes. So we're still going to be plotting 5 things when we talk about tangent. Just like for sine and cosine, how we did a middle up, middle down, middle. We were plotting 5 points. Here, we're going to be plotting our center point, and then these kind of middle points that are off to the sides, and then our asymptotes. The standard form of the tangent graph looks the same as the standard form of the sine and cosine. And we have an a value in front. That a value does not define amplitude because we don't have amplitude, but it does define that height of those middle points. Okay, the way that an amplitude would in a sine or cosine.
Please excuse this interruption. Megan Manuel and Malcolm Cusack, please come to the high school office.
It is important to note that the period for the tangent graph is only pi over b instead of 2 pi over b. So for sine and cosine, we've been working at 2 pi over b. For tangent, it is just a plain pi divided by b. Tangent repeats itself more often than sine and cosine do. Our asymptotes are going to be at half of the period. So once we found our asymptotes, or once we found our period, we'll multiply that by a half, and that'll give us the location of our asymptotes. For this one, that a value in the front, I wrote the word amplitude. It's not technically an amplitude because it goes up forever, but we'll kind of think of that same thing is going to be 3 over 2, or 1.5. The period is just pi divided by b. So pi divided by 4. This thing is going to be super tiny. We're going to set up our graphs the same way that we set up sine and cosine. Taking 3 lines of paper and flipping and calling it a pi. But in this one, we actually need to know where pi fourths are. This is like ridiculously tiny. In fact, it's so tiny that I think I'm going to change my scaling and count by a half.
I just put it out.
So that's a half of pi and a fourth of pi. On tangents, you will also need to go a little bit backwards, not super far, but a little bit backwards. So I'm going to mark out that negative pi over 4 as well. The first thing that we're going to want to plot in our tangents is going to be our asymptotes. The asymptotes are located at half of the period. So for our asymptotes, we're going to take our period and multiply it by 1/2. So we get pi over 8. So then on our graph, at pi over 8, we're going to have our asymptotes. Pi over 8 would be halfway out to the pi over 4. Then within there, I want to plot 3 points. Right at the origin is going to be the center of our graph. Halfway between that point and the asymptote, exactly in the middle of that point and the asymptote, we're going to have our point that's kind of defined by the amplitude value, which is going to be 1.5 for this one. And halfway back again to the left between the asymptote and that center point, we're going to have a point down, the amplitude value at 1.5. So it's going to start out from the bottom, following along that asymptote, cut through the middle and turn to go up. It flattens in the middle, okay? So make sure that it's taking its turn right in the middle there, that it's going pretty much straight up, and then it takes a turn to cut through that middle point. Just like sine and cosine, I want you to plot 2 as long as 2 will fit. So I'm going to go out another middle here to make my asymptote. Right through the center, so right at that pi over 4. Halfway between that point and the asymptote, I've got my up point. And halfway back to the left, I get my down point. These get arrows on their ends because they do keep going up and down forever.
So those solid lines, they just follow. What do they? How do you decide like where they go?
They're going to follow right along those dotted lines. It can't cross over those dotted lines, so those dotted lines kind of create a boundary for it that has to stay within there. Yeah, this one is really tiny. It's harder to plot when they're tiny. Our next example, I'll have a bigger space to work with, so we'll be able to see that one a little bit more clearly. So in this one, what we've been calling our amplitude or our height, still given by the A value, is 3. The period for tangent is just pi divided by b. That's one of the biggest changes, I mean, other than the fact that it looks totally different, but one of the things that students get wrong most often is since we've been working with 2 pi over b, 2 pi over b, 2 pi over b, you need to make sure that when we're talking about tangent, we just do a pi over b. How do I divide by pi halves?
Multiply by 2.
Multiply by 2 over pi, which is just going to give me 2. Then our asymptotes are going to be at half of that, or 1. The asymptotes are at half of the period. Since this one isn't in terms of pi, it's in terms of 2. I'm just going to take 2 lines of paper and flip it out and call it a 2. We need to go enough to have 2 off to the right like we've been doing, and then 1 off to the left because we're going to have to do that little asymptote over on that left-hand side, so we just need a little bit of room over on the left-hand side to get that asymptote, but we want enough room to do 2 off to the right like we have been doing.
So there's always going to be 1 to the left.
Yep, we'll always need to put 1 marking over to the left. So the first thing we plot in is our asymptotes. The asymptotes are at 1. So at positive 1 here and at negative 1, we get our first set of asymptotes. Then we're going to have a point at the origin. Halfway between that origin point and the right-hand asymptote, we're going to be up at a height of 3. And halfway between the origin point and the left asymptote, we're going to be down a height of 3. I'm going to connect those points and let it kind of curve through the middle. Don't connect them with just a straight line. It takes a curve through the middle. Then we're going to put in another asymptote. To determine where to put in the next asymptote, we use our period length. The asymptote should be a period away from each other. So if this asymptote is at 1, and they should be a period away from each other, or 2 away, my next asymptote would have to be at 3. Okay. The asymptotes should be a period apart from each other. And we do the same set of 3 points. Questions? The next 2 examples in your notes end up having a really tiny period, and they're just going to be difficult to plot. So we're just going to jump down to was example 7 in your notes, where we start talking about how we move these things around. We learned how to move around sine and cosine yesterday. All functions behave the same way. Not only all trig functions, but all functions. Any kind of algebraic function behaves the same way when we think about shifting and flipping. So we're going to follow exactly the same rules as we did yesterday as far as the shifting and flipping go. So for this one, our amplitude is going to be, we're going to say 1. Amplitude we're always going to think of as a positive, but there is a negative there, and what that negative is going to do is going to flip it. So instead of starting low and ending high, it's going to take more of this kind of a shape, where it starts high and ends low. The period is pi divided by b. What's b? 1. So our period is just going to be pi, which means our asymptotes are going to be at a half of pi. Asymptotes are at half of the period. And what is that plus pi over 4 going to do? Shift it which way? Left. Sideways shifts go backwards. Tangents, I give myself more room to do stuff over to the left, especially on this one where I have to shift to the left. I'm going to take 3 lines of paper and flip it and call it a pi. And I also need to go backwards a negative pi. Before plotting any of our features of our graph, our asymptotes or our points, we need to take care of the shifting. So we need to shift this thing back 1/4 of pi. So I need to take my pi's and divide them into 4 equal pieces. Then I'm going to go back 1 of those to the left. And that creates what's kind of like our pretend y-axis. That's going to be the center of our graph. So our asymptotes are at pi over 2, or a half of pi. Each of these little red tally marks and the black ones along the axis represent 1/4 of pi. So if I need to go to a half of pi, how many do I need? 2 of them. So I'm going to go 2 markings away and put asymptotes. Okay? Each marking is 1/4, so if I want to go to a half, I need 2/4 to get over to a half away. Right on that shift line is going to be like our origin, so that's where our center point's going to go. Our amplitude, or our height of these offset points, is just going to be 1, but we're going to flip it so that on the right-hand side it's down and on the left-hand side it's up. Then I want to repeat the same pattern over one more time. The period is pi, and that's how far away from each other the asymptotes should be. So if each of these markings represents 1/4 of pi, and I need to go to a pi, I need to go 4 markings away to get to another asymptote. Right in the center of that is our middle point, and then our offset points. Lots going on in this problem. Questions? Okay, for this one, what's the amplitude?
1.
1. It's what's multiplied in front of the trig function. There's nothing multiplied in front of the word tangent. The period is pi divided by 1 because there's nothing multiplied by the x. So that means our asymptotes are going to be at 1/2 of pi. The -2 in the front does what?
Shifts it up or down.
Moves us down 2. And the minus pi halves does what?
Shifts to the right.
To the right. There's a positive in front of the tangent, so this one's not going to be a flipped one.
Can you go over the part of the parentheses again?
What is in the parentheses with the x is a side-to-side shift, and it always goes in the opposite direction of what's indicated by the sign. So when we're subtracting, we're actually going to go over to the right. If we're adding, we're actually going to go over to the left.
And then what does the x do? Nothing.
The x is just our variable. It just has to, that's what's kind of creating that we have a function,
Okay.
but we don't do anything with it. Alright, so first we'll get some markings on here. Take 3 lines, flip it. I'm going to call it a pi. With the period of pi, I'm going to go out to twice of that on the right. And I also need to go back on the left. Then we need to take care of our shifting before plotting any of the features of our graph. So first we're going to shift down 2. I'm going to go down 2 lines. That's going to create the new middle of our graph. So that point that's been like on our origin point is going to be on that line. And we need to go to the right a pi halves. So I need to take these pi's and cut them into halves. And I want to go to the right one of those. Kind of missed it, but we'll pretend. Just make my mark bigger. Then we're going to make our asymptotes. Our asymptotes belong pi halves away from that, that new vertical line. So each of the markings on the axis represents a pi halves. So I'm going to go 1 marking away and make an asymptote to each side. So one of our asymptotes is the original axis. The other one is at pi. Then our center point, that's been our origin point, is going to be right where those 2 red lines meet. Halfway to the right, I'm going to go up 1, and halfway to the left, I'm going to go down 1.
What does the -2 do?
Moves the middle line down 2. So that's why our point is 2 below the x-axis instead of right on the x-axis. The period length is pi, so the asymptotes should be pi apart from each other. So I have an asymptote at pi. My next one, a pi away from that, would be at 2 pi. And then the same set of 3 points. Questions? This next example ends up with a really tiny period again. It just makes it too hard to graph. So we're just going to go on to example 10, the last example. This graph literally has everything that can possibly happen to a graph happen in it. So this is like if we can manage our way through this, then we can manage our way through anything, because this literally has everything that could possibly happen to a graph happen in it. What's the amplitude? 1. But there's a negative in front of there. We don't say we have a negative amplitude, but we're going to take our graph and flip it upside down. So it's going to start high and end low. The period is going to be pi divided by 2, because there's a 2 multiplied by the x. And again, remember, tangent is just pi divided by, not 2 pi divided by. Our asymptotes are then going to be at a pi fourths. Half of the period makes the asymptotes. Inside of those parentheses, the minus 3 pi over 4 does what? So it goes to the right.
How many would it go over to the right?
We're going to end up having to break our pi's up into fourths to get our asymptotes of pi fourths. So we'll move over 3 of those pi fourths markings. It's a 3/4 of a way to a pi. And then that plus 1 at the end is what? Up 1. All right. So we'll start by just making our axes and doing our normal scaling. I always just go back 1 mark to the left, and then on the right I want to make sure I have enough for twice the period, and this one does. Then we take care of our shifting lines before we start plotting any of the features, the asymptotes or the points. So this graph needs to shift up 1. So I'm going to go up 1 line and give myself just a little guideline that that's supposed to be my new middle level. And I need to go over 3/4 of pi, so I need to take my pi and cut it into fourths. And when I go over...
Please excuse this interruption. All high school jazz band members, please come down to the stage. Thank you.
When I go over 3/4 of pi, that doesn't give me very much room to kind of keep working over on the other side. So I'm going to go ahead and go out another pi, so I have more room to be able to complete my cycles over there. I also, since I'm drawing those lines in so light, as soon as I have them drawn, I just put a point on it, because tangent always goes through that origin point. So as soon as I have my lines drawn on that, I just put my origin point right on there. Then our asymptotes are 1/4 of pi. So each of these little markings represents 1/4. So I'm going to go 1 marking away on each side.
What is the little red line?
The horizontal one or the vertical one?
Vertical.
The vertical one is at 3 pi 4, so that's because of the sideways shift.
Oh, okay.
Then this graph was flipped upside down, so as I go to the right, I want to go down, and as I go to the left, I want to go up. So it starts high and ends low. Then you need to do one more cycle. We've got enough room to do lots on either side, and it doesn't matter to me whether you do one more to the left of this one or one more to the right of this one, but on one side or the other, copy over this set of points. So my period is pi halves. Each marking is a quarter, so I need to go 2 markings away to make another asymptote. And then I copy over the same 3 points. So you only need 2 sets, but we actually have room for lots of sets here. No, and I could even keep on doing more. So tangent really keeps repeating itself forever and ever, so it doesn't matter where you put your second copy to one side or the other. Okay?
How do you know where to make the second line?
The next asymptote,
Oh yeah.
it should be a period length away from the first asymptote. So each of our little divisions represents a pi fourths. So I need to go pi halves away or 2 markings away to make my next
So
asymptote.
you just double the period and that's how many you have to go?
No, you want to go the period length. You want to go pi halves. So each mark is pi fourths.
Oh, so you go
So 2 pi fourths makes a pi halves. Homework is from both 14.1 and 14.2. In 14.1, there's no shifting, and then in 14.2, the graphs are shifted.